until now, we have only done central angles, where the central angle is the vertex is at the center and it's exactly equal to its arc. Today, we're going to do inscribed angles. Now, an inscribed angle is where the vertex is on the center of the circle. This actually is very easy math, but what scares me is that you're going to be in a hurry and you're either not going to look for the right angle or arc, or you're just going to get things confused. All you're really going to be doing, for the most part, is either dividing by 2 or multiplying by 2, which is not hard. You just got to keep straight. When do I multiply by 2? When do I divide by 2? All right, so if you've got an inscribed angle is an angle with the vertex on the circle and its two sides are chords. So it goes from, both of the endpoints have to be touching the circle for it to be a chord. It does not have to go through the center to be a diameter, but it could. All right, now, the intercepted arc is the arc that lies between the endpoints of the inscribed angle. So I'm going to draw on my angle real quick, okay? My angle here is A, B, C. What are the endpoints of that angle? A and C. So the intercepted arc, I'm going to color that in pink. If the angle is ABC, the arc name is going to be the first and the last letter, because the vertex is on the circle somewhere. So, inscribed angle, vertex on the center. The intercepted arc is the arc where it opens up to. Now, the degree of the inscribed angle is not the same. Actually, it is equal to half of the arc. So, the measure of the angle is 1/2 the measure of arc, AC in this case. So, if I said to you, let's go easy numbers. If arc AC is 100, the angle's half of that. What's the angle? 50. How'd you get 50? Divide by 2. Half of 100. Okay? Let me go with another easy number. If I tell you the arc is 150 degrees, okay? The arc is 150. How much is the angle?
75.
How'd you get that so easy? Divide by 2. Half of the arc is the angle. Now, what if I flip it around? What if I tell you that this angle is 20 degrees? How are you going to get the arc?
20.
So you're going to multiply. If the arc, okay, if I want the angle is half the arc, that means the arc is reversed 2 times the angle. So if the angle's 20, 20 times 2, the arc is 40, okay? What if the angle is 80?
160.
You're going to multiply by 2 and get an arc of 160. So I told you, the math is not hard. Keeping it straight in your brain is going to be where you mess up. So the inscribed angle is half the measure of its arc. All right, so let's talk about what happens if you intercept a diameter. Well, you can figure that out for yourself. If we look at, if we want the measure of BAC right here, okay? BAC opens up to this diameter. Now, what is the degrees for this part of the circle? So the diameter cuts it perfectly in half and creates a semicircle. How many degrees are in a semicircle? 180 degrees. Now use what I just taught you to find this angle. The angle is 1/2 the arc. What's half of 180? 90. So that is a 90-degree angle. So if the inscribed angle intercepts, meaning it has its endpoints at the diameter, then it is a right triangle. So the measure of BAC is 1/2 of 180, which is 90 degrees. That only works if I know that this is my diameter and I know for a fact that that is truly a semicircle, which is 180 degrees.
How would you know if there's a semicircle?
So it's going to have to go through that, your endpoints would have to connect, go through your center and make a diameter. That's how. All right, so now, overlapping arcs. This just starts to get kind of crazy when you start to kind of go cross-eyed. So, you know, I love color. I like to highlight and draw on stuff. Alright, if two inscribed angles intersect the same arc, then let's figure out by the angles. So, I'm going to color my two angles. This one says the measure of angle BAC. That will be from here, BAC. What is its arc? BAC is at arc BC. Alright? What other angle has endpoints at B and C? You start from B, you have to go D to C. Okay? These two angles have the same intercepted arc. So what does that tell you about the two angles? They are equal. So if two inscribed angles have the same arc, then the angles are congruent. So if this angle was, let's say, 60 degrees, what would each arc equal? 30 degrees. You take half of it. If you know the arc, take half to get the angle. Alright, so the measure of angle BAC is congruent or equal to the measure of BDC. If they're going to be overlapping arcs, and they've got to have the same, overlapping angles have got to have that same arc, you've got to have the same beginning and ending letter, because that tells you what your arc name is. Okay?
Well, can it be like CDB?
You could absolutely name it CDB. I just tried to keep it the same so it looked easier. But it's totally, yeah, it's the same thing. There's actually another set. ABD shares the same arc as ACD that you could have picked. Alright, so here's the basic thing that you got to remember. The inscribed angle is half of its intercepted arc. Inscribed angle is half the arc. Okay, so let's look at number one. In number one, I need you to find each value, arc measure, or angle measure. I need you to find the measure of angle WXY. So, WXY, what is the arc that intercepts or opens up to? WY. And what can you tell me about arc WY?
62.
It's 62 degrees. What is the relationship between the inscribed angle and its arc? Divided by 2, or half. So, that angle is half of 62. What is half of 62? 31. Now, that's an angle. So, do I need a degrees? Yes. Every angle and arc needs a degree. So, the reason I halved it is because I knew the arc. The inscribed angle equals half of the arc. Okay, look at this one. I need arc DGF. Okay, so if I've got arc DGF, what's its inscribed angle? DEF, which is 113. Now, the angle equals half of the arc, but I know the angle. So how do you go backwards? You're going to times it by 2. It takes 2 angles to equal the arc. So what is 2 times 113? 226. So 226 degrees. I guess I could have wrote it over here.
Why do you have to multiply by 2? Or multiply by 2?
So that's just how it works out. So it's always half.
Is that because it's on the other way of this?
Yeah, so it's because it's reversed. The arc is half the angle. So the arc is half of this angle. The angle is half of the arc. You could set it up like an equation and try to solve it, but that just takes too much time. So if you're going to reverse it, you're going to times by 2. Alright, so let's look here. I need the measure of angle PQR. I want this angle right here. This angle opens up to an arc. And that arc happens to intercept the diameter. So, because it opens up to this diameter, what's the measure of that arc? 180. So, how do you know that's 180? It's the diameter, which means it's a semicircle. Okay? Now, the arc is 1/2 the angle. I said that so backwards. Let me start again. The angle is 1/2 the arc. So I take 1/2 of 180, and what is that? That is 90 degrees. So this is actually a right triangle. Now these are very simple pieces that we've got to make sure that we can figure out these small numbers, because tomorrow we're really going to hit hard with algebra, throwing in expressions, and you've got to know that that equals 90 degrees. All right, next one. I need the measure of arc BC. Now I want you to look carefully. Does arc BC have an inscribed angle? No. I do see an inscribed angle, but what does this inscribed angle open up to?
AC.
It opens up to AC right here. So, if this inscribed angle is 47, the angle is half the arc. So how do I go backwards? Multiply. 2 times 47 takes up how many degrees? 94. Okay. What part of that circle is 94 degrees?
AC.
Arc AC. You want arc BC. How do AC and BC fit together? They equal 180. So 180, take away the 94 to give you 86 degrees left over for that semicircle. All right, let's keep going. Let's flip over to number 5. All right, so you've got to carefully keep in mind what you're supposed to be finding. I need to find the measure of angle JKL. JKL. This is the angle I want. All right, it opens up to arc JML. Do you know arc JML right now? Nope. Could you find the measure of arc JML?
Yes.
How?
You did 360 minus 53.
360 minus the 65 minus the 53 that don't include in JML. And what is that?
240.
All right, so I got 242 degrees right there. Now, if this is a multiple choice test, I'm putting 242 as a possible answer, but it's wrong. 242 is the measure of the arc. What did I ask you to find? The inscribed angle. What is the relationship between the inscribed angle and the arc? All right, so you take half of the arc to get how much? 121, and you gotta have degrees. So, the inscribed angle equals 1/2 of the arc. All right, so the next part, they're asking me to find 2 different angles. I'm going to color those real quick. The measure of angle RST. RST. That's an inscribed angle because the vertex is on the circle, and what is its arc? RS. Okay, or RT, I can't read. I said what you said. All right, so RT. How are you going to find arc RT? When you know 75, 139, and 64. Add them all up and subtract from 360. I personally just go 360, take away 64, take away 139, take away 75. What's that leave me with?
82.
My girl tells me 82 degrees. Okay? If the arc RT is 82 degrees, how do I find my inscribed angle? Very good. My angle is half of that arc. And what is half of the arc 82? 41 degrees. So RST is 41 degrees. Now let me move on and find RUT. RUT. That's an inscribed angle that opens up to how many degrees? An arc of 82. So if the arc is 82, take half of it, it is also 41 degrees. It's important that you realize these two angles are equal to each other because they have the same intercepted arc. Tomorrow, what I'll do is I'll give you two expressions like maybe this is 3x plus 5 and this one's 10x minus 7. And you would need to know that those are equal and we'll set them equal, find x. Alright, so now we're going to just dip our toes into the algebra portion of this, okay? I need you to look at 7. I need you to solve for x. This angle, CDE, that is 8x minus 9. What is, this is my inscribed angle, what is its intercepted arc? B, C to E, 158. What is the relationship between this arc and that angle?
It's that times 2.
So, you got one of two ways. The angle, 8x minus 9, is half of the arc, right?
You do 158 over 2.
158 divided by 2, yes. Yeah, you could go ahead and do that part right in your head. That'd be fine. Alright, so I've got 8x minus 9 equals 158 divided by 2 is 79. Solve for x, I'm going to add my 9. My 8x equals 88. I'm going to divide by, not x, you silly, silly lady. Divide by 8. And x is going to equal 11. So, if you said the angle equals 1/2 the arc, you would get 11. There's another way to think about this though. Think about it in reverse. If the angle is half of the arc, what does the arc 158 equal? It's got to have two angles. Okay, so here is or. The arc is 2 times the angle. Now, what should I get? I should get 11, the exact same thing. So when I do this, 158 equals 2 times 8 is 16x, 2 times negative 9 is negative 18. I add 18 to both sides. 16x equals 176, and when I divide by 16, my x equals 11. It does not matter which way you think about it. You're going to get the same answer. What you got to remember is the angle equals half the arc, but that also means the arc is 2 of the angles. Alright, so look at number 9. I know that this angle right here is 67. It opens up to this arc. Are these two equal to each other? No. The angle equals how much? Half the arc. Or you could say 4x plus 58, the arc is 2 of the angle. Or you could say the angle equals 1/2 the arc. Either way, you should get the same answer. Okay? So, if I do 4x plus 58, 2 times 67 is 134. I minus 58 from both sides. So I minus 58, I get 76. And when I divide by 4, 76 divided by 4 gives me 19. I was thinking the arc equals 2 times the angle. Here, I went with the rule. The angle equals 1/2 the arc. Now here's the only thing that scares me about this. When you multiply this 1/2, what all do you have to multiply it by? Everything. I'm afraid that somebody out there is going to forget to take half of 58, which is 29. So I'm going to minus 29. I'm just going to switch this around. So 67 minus 29 gives me 38. And when I divide that by 2, I get x equals 19. Do you have to show your work both ways? No. I would like to see you set up which way to write down which way that you decide to go. And then from there, if you want to do it in the calculator, that's fine. But if you set it up and you show me where you started mentally, that's going to help me figure out where you went wrong if you get it wrong. Okay? So, biggest thing that you have to remember is the inscribed angle is 1/2 the measure of the arc.